service, and you want to make sure that it works. And your service is somewhere deep in a microservice architecture. And you want to test your changes before they go to prod. So if you're a developer, you want to make some changes and make sure they work before you commit them. If you are an operator and you're given a build, you want to make sure that build isn't going to take your site down when you deploy it. You just want to have some confidence that your changes do what you think they should do. So your architecture might look something like this. There might be some kind of web front end, and then maybe an API server, and then your foo server, which is kind of deep in the stack, and then it talks to storage. And generally, we're going to be talking about RPC. So as in the previous talk, that can be REST, that can be gRPC, any RPC protocol. And so if you work on a front-end service, like the web front-end service, things are usually pretty easy. You can make some changes, you can deploy it, you can test it, you can see the effects of your change and see if it looks good or if it looks bad. If you work on a service that's deep in the stack, like foo is here, it gets a lot more difficult because you can't just point your browser at foo. It's not a front-end service. And so it can be a lot more difficult to figure out whether things are working. So the first thing you probably are going to try to test your service are unit tests. And unit tests are great at testing your code, but they only test small pieces in isolation, or at least that's the intent behind them. So you can have unit tests that all pass, but of course your service doesn't work as intended. And another thing about unit tests is that they kind of test the implementation directly. So if your service changes, if you refactor it, if your implementation changes, you usually have to rewrite your unit test as well. Or you may get to a situation where because your assumptions about the way your service will work have changed, then your unit tests may be failing even though your service is actually working fine. So they test implementation rather than functionality often, which is sometimes useful if you want to be able to test your code, but it may not be exactly the test that tells you whether your service is working properly. And a lot of the time, unit tests require stubs or mocks to work properly. And you can get into this situation where you've got so much testing code and so much mocks and so many mocks and stubs, you end up testing your mocks more than your actual code, which is kind of a big waste of time. And it doesn't test interactions. So unit tests are necessary, but they're not sufficient. They don't really test the whole story. So the next thing you might move to after that is you might try to do functional testing. And this is where you issue some kind of request to your service, and you get some kind of response back, and you look at that response, and you see, is this the response that I was expecting to get? Is this the correct output? And this can be done manually, or you could do this with a test script or some kind of test harness, or you could do this in CI. Basically, you just kind of, it's like black box testing for your service. You send in a request, you look at the response, make sure that everything is as you think it should be. The gotcha there is the words, as you think it should be. So, what is a valid input? You're sending these valid inputs, these so-called valid inputs to your service. What is a valid input? Now, presumably you have some kind of spec or interface definition for your service, and so you're issuing, correct, valid requests according to that spec. But how often is it that, a service that implements a spec and the clients that consume the spec all completely agree on the meaning of the spec and are completely on the same page? Right? That doesn't usually happen. Usually people have different ideas about what that means, or there's corner cases that aren't defined, or people ignore the spec and kind of do their own thing and still expect it to work. And the flip side of that is true as well. What is a valid output? I mean, you may get an output from your service and you say, yeah, that's right, that's what it should be. But your clients that actually consume your service may say, hold on a minute, that's not right. That's not what we expected to get. And so, even if your code is correct according to spec, when you deploy it to prod, it still may break your service. It still might break your site because your clients are doing something that you didn't expect, or that you didn't, you don't think that they should be doing. So you have to think about how your outputs are going to be used by other services in real life, not just what is technically correct. And so this leads to needing to be bugwards compatible rather than backwards compatible. If you've got clients that are depending on the behavior of your service, and you make a change to that behavior, even if the new change is more correct, but the clients are depending on the old behavior, this will break your site. go down when you deploy, even though you haven't done anything wrong. So that's why integration testing is really important. And there's kind of 3 types of integration testing that I want to talk about. They're shared staging clusters, personal staging clusters, and then testing and prod, everyone's favorite. So a shared staging cluster might look something like this. You might have a new version of your service that you want to test, and so you deploy it to the staging cluster. And you start hitting the front end with requests and see if it looks good. The problem is that if this is a shared cluster, other people are deploying things here too. So you might have Alice's web front end that she just built and threw up there. You might have Bob's API server. What's in the database? It's whatever garbage data people have written in there. And so if things look wonky, you really have no way of knowing whether that's because of your change, because someone else's change, because of the weird data in the database. Like, who knows? It's total pandemonium. Because there's no isolation. You've got your service that's doing its thing, and then you've got other things that are changing. There's no way to isolate your changes. So you have no confidence about whether breakages are to you or to someone else, or what even is going on. So you might think, okay, well, that's obviously not viable. You need to have a personal staging cluster that's all your own. You deploy a version of your service, and no one else can deploy that cluster, so you've got perfect isolation, and you're fine. But you want to do integration testing, which means you need to deploy, if you deploy the food service, you need to now deploy the API service to talk to it. Well, okay, you deployed the API service, and now you have to deploy the web service to talk to that. Okay, finally, now you can make requests to the web service and make sure that everything is working. And this is really good because this gives you perfect isolation. You can look at the behavior of the front-end service. You can see that everything is working like you thought it should. If you make changes to your service, you can see that those changes are reflected in the front end. And this is great. This is exactly what you want out of a testing system. But this is very expensive because you have to be in charge of deploying the entire cluster. If you have an enormously complex, microservice architecture, you have to deploy every service that talks to you and every service that you talk to transitively. And so not only is this extremely difficult and time-consuming for you to do and to maintain this cluster over time, but it's also very expensive in terms of resources because every developer in your company needs to deploy a complete copy of your entire architecture. That's crazy. So you want to have this isolation where your changes kind of don't mess with other people's changes, but you want to use shared infrastructure, so just deploy to prod, right? What's the worst that can happen? Actually, deploying to prod is great because you get to test it on real-world data. You get to test it at real-world scale. You know that you're talking to other prod instances, so you get a perfect test. This is kind of the best test that you can do. Of course, if something goes wrong, then you're surfacing those errors to your users, and that's not great. All right, so one thing that you can do to kind of get the best both worlds is you can do per request overrides. So what does that mean? So the first thing you'll want to do is you want to deploy your modified version of your service into the prod cluster, but don't have any traffic going to it. So here we see that we've deployed my own copy of the food service right next door. It's not taking any traffic, it's not disrupting prod traffic in any way. Prod requests are still going through their normal flow, everything is fine. But what we can do is we can issue special test requests to take an alternate path through the system. And so we can have these special requests that you issue as a tester that go through the regular prod, front-end, API service, but then instead of going to the regular prod food service, they take the alternate path and they go through your staging service. And so these test requests let you test what the prod infrastructure would look like had you deployed your service. But regular, normal user-facing traffic is completely unaffected. So this is awesome. This should be really exciting because you can do a perfect test without affecting prod traffic. This is like deploying to prod, but without the danger. So how do you do that? So this is where linkerd can come in. And there are a number of ways to do this. You could have libraries in your code that kind of do this dynamic shifting, where if a certain context variable is set, then you shift traffic from one place to another. But linkerd is kind of an easy way to do this without having to modify your application code. So what is linkerd? Linkerd is a proxy that runs alongside your application, runs in a separate process, and it handles your network traffic for you. So instead of sending requests to another service as you normally would, you send that traffic to linkerd and it proxies it for you. And it takes care of service discovery, load balancing, and all kinds of other stuff that you generally want. But particularly, it takes care of dynamic routing, and that's what we want to use here. So this is what your architecture might look like if you had linkerd. So you run linkerd alongside each instance of your service, and the network traffic goes to linkerd first, then to the service, then back to linkerd. And so linkerd kind of wraps all of the network calls. And so you go, web front end through linkerd to API, through linkerd to foo, through linkerd to storage. And what this now means is that once that's in place, you can stick a header onto your requests that acts as an override. So this, L5D dtab header, says anytime you would talk to the foo service, instead talk to my staging version of that for the lifetime of this request only. So regular prod traffic is still, doing the normal thing. It's not impacted at all. But any request that's issued with this special header is going to have this override applied to it, where it goes to the regular prod web, regular prod API. But then instead of going to the regular prod foo, it's diverted and goes to my staging version. And so this lets you stage changes to your service kind of in the context of your whole prod infrastructure, which is really, really cool. So just to summarize kind of really quickly all the different kinds of tests that I talked about. They've got unit tests, which are great. You should definitely do unit testing, but they don't test kind of the full functionality of your service. They're kind of tied to the implementation. Functional tests do, but they are tied to your assumptions. So whatever assumptions you make about what the correct inputs and outputs are for your service are going to be reflected in those tests. I've seen a lot of tests, and I've written a lot of tests that are, say, assume that the output is what I assume the output should be, which is not really a useful test. You can use a shared staging cluster, and that, might be a good way to get off the ground if you don't have a lot of developers, or if you kind of know what everyone else is doing, but it really doesn't scale up. It becomes chaos as multiple people try to use it at the same time, and stomp on each other's changes and whatever else. If you've got a personal staging cluster, that works great, but if your service architecture is large, then it's not really practical to have your own complete copy of everything running on your laptop or as your own personal cluster. And then testing in prod is like a perfect test, but again, it's very dangerous because you're exposing users to anything that goes wrong. And so per request overrides kind of give you the benefit of testing in prod, but without the danger, at the expense of having to have a way to do it. So you need either linkerd to dynamically shift the traffic like this, or some other way of dynamically selecting which service you want to talk to at each hop in the architecture. So if you want to know more about linkerd, there's some more information. And if you have any questions or want to chat about it, I would love to chat about it.
The per request override require that you permeate a header across all services?
Yes, so the question was, do you have to forward a header in your service? And yes, you do. It's dependent on what protocol you're using. So for HTTP, you forward a header. For other protocols like Thrift, you have to propagate context information. But yeah, you have to propagate that through your service in order for that to make it way through the stack.
One is that on the personal staging thing, the one solution that we come up with is to be able to run tests to be able to figure out which services are executed on a test suite, and then just spin up containers for those services. So we set up a cube and then bang, or a pod, and then launch those containers within that for that particular test set. The other one is that if you're doing this redirect override in production, you have a danger of hitting production data and altering the data in a bad way. So you're still not completely safe.
Yeah, that's right. Yeah, so for your first point, where you only spin up containers that are going to be used for the duration of a test. Yeah, that's great. I think what happens a lot of the time in practice, if you're kind of doing these end-to-end tests, is that you end up hitting a lot of your architecture. Depending on the nature of the test, you end up hitting a lot of services for any given test if you're trying to test kind of end-to-end functionality.
If they're small services, it doesn't cost very much.
Sure. And then with respect to accessing prod data, yeah, absolutely. You still are in a dangerous situation because you are talking to prod data. You can imagine issuing an override where you talk to a staging database instead. I mean, that you could do that too. But yeah, in this example, you're talking to prod data, so you definitely have danger of corrupting that.
To exactly that point, in this example, say I don't want to use the production database, but you only have one dtab entry to say, it's Alex, you only own one microservice. You don't own the database.
Mm-hmm.
And there might be a lot of different services behind you.
Mm-hmm.
Can you add multiple tags that say, if I'm doing anything below me, by definition, has to be on its own test tab? There's test dtab.
Yeah, right. That's a good question. So you definitely can specify multiple rules in your header here, and you don't need to be the owner of the service in order to do that. You can say, I would like to talk to a different downstream, instead of the regular one. I would like every time I talk to the database, I'd like to talk to this other database. Every time I want to talk to this service, I want to talk to that service. You can have kind of as many rules in there as you want.
So they're stacking the rules, and how much is this something Buoyant's going to do to make it? I mean, you guys have got part of the solution, but in reality, we need something that will enforce test all the way down. You understand? Because you can't hit the primary production database. If you're doing an update, it would be that.
Right, yeah, so.
And if there's 5 level services below you that you don't own, something needs to make sure that never happens.
Right, so if you have an override rule that says, anytime you would talk to the production database, talk to the test database instead, that rule will be propagated and forwarded to all of the services that you talk to, so they will obey that rule as well.
I think the difficulty is you're Alex owning foo, you're not the person who has n levels down below it. You don't know necessarily what they do.
Right, but as long as they're using linkerd to do their communication, it will obey these rules, right? This is not logic that's built into the application, it's built into linkerd.
Yeah, I guess I was trying to say you need something that will automatically generate the rules so the Alex foo person doesn't actually have to know everything below it.
Sure, yeah, sure. So the person issuing the request needs to know what kind of overrides to apply.
Everywhere.
The service itself doesn't need to know. The service itself is completely agnostic to what's going on around it.
So that's the question I'm asking. So you guys going to figure out a way to automatically generate those rules, or is it still going to be Alex foo owner?
I mean, yeah. So I guess it's a question of tooling. We don't really have any tooling right now to say what's a safe rule and what's an unsafe rule.
Yeah.
I think that's going to depend on your architecture. But if you were to use this, in prod, you would probably need some kind of tooling around. These are the types of rules that you can set. These are types of rules that are unsafe.
Yeah.
If I got it correctly, you put the dtab in the HTTP request coming in to the initial linkerd.
Yes, that's right. And then that will get propagated, assuming your application's forward headers, they'll get propagated all the way down.
So these are uppercase forward headers.
Yeah, that's the gotcha.
So if anyone comes to my HTTP and puts in, /AlexFoo, and they hit your non-production endpoint, is there some low security that linkerd does to prevent only developers at your company can hit this keys or IP, whatever?
Yeah, that's a good question. Yeah, so once you can specify these headers, you can kind of do anything you want to the routing topology, which is why you probably want some kind of front end in front that strips out these override headers from requests coming from the outside world. So if you had Nginx in front, for example, you could say if this request is coming from the outside world, strip out these headers because we don't want users to be able to access whatever service they can specify.
How does this affect your analytics? Do you filter out these test strings or leave them in so that your services can respond to these? If you have some sort of auto-scaling based on analytics, like you auto-scale based on the test data, or ignore ignore that?
I think that's kind of up to you. You know, linkerd will take care of the routing. How you kind of interpret the data is up to you, whether you want to count those or not. I mean, they're real requests in the sense that they're going there. They're test requests in that you know they were issued by someone from someone that's setting this header, presumably that's inside the front end.
Have you interacted with data after it's been filled with test queries from inside your request server? And does it make it sort of harder to use the data after it's been collected that way? It seems like, depending on your load of tests, it might be significantly increasing your production load.
I mean, I think it's pretty standard to kind of discount test requests. If you're doing analytics for business reasons, you probably don't want to count your test requests toward that. Be they, like this, or like if you were just doing a load test, for example, you wouldn't want that to affect your business analytics.
How much of a performance hit is
In terms of latency, very small, less than a millisecond per hop. In terms of memory, linkerd runs on the JVM, so it's got a fairly large memory footprint. We've gotten it down to, in some cases, about 50 megs, but that's still going to be larger than something written in a native compiled language. Does that answer the question?